Hi, everyone. Thank you for joining me. My name is Steven Tirana. I'm a certified Kubernetes administrator, a Jenkins contributor, if 8 lines counts. I'll show you why it matters in a little bit. I have built continuous integration, continuous delivery platforms for places like the National Science Foundation, CMS, GSA. So I work at Booz Allen Hamilton, or a federal consulting firm. So today we're going to talk about DevSecOps and how to drive adoption through shared libraries, and specifically through a framework that we've been working on over the past year to facilitate some governance and reuse. So today we're going to talk about Booz Allen's modern SD approach, give you some context of the kind of work that we do. What exactly is DevSecOps, because everyone I talk to has a different definition of that. Pipeline pain points and sort of the driver of why we went through this effort. And then Booz Allen Solution Delivery Platform, which is what we call our Jenkins pipeline framework. We're going to do a live demo, so everyone cross your fingers for me. And then we're going to go into a little bit of how it works and what exactly it can do. So at Booz Allen, we do a lot of modernization efforts, a lot of cloud-native microservice development, running in AWS and Azure. Modern software delivery for us involves things like tier automation, continual learning, agile methodologies. At the center of how all of our teams work is DevSecOps. So it's really the core of how all of this modern software delivery and microservice applications get from developers' laptops to production. So what exactly is DevSecOps? I could probably give a talk on this slide by itself, but it's the idea of incorporating security into every step of your software development lifecycle. So that includes things like making sure your third-party dependencies are secure, doing static code analysis to make sure the code as written is secure, doing some penetration testing, image scanning, continuous compliance, and accessibility assurance. So incorporating all of these aspects into your continuous integration, continuous delivery, Jenkins pipeline. That's in addition to all of the other things that we've been talking about for years that should be incorporated into your CI/CD pipelines. So that's unit testing, functional testing, any kind of testing that you can think of. And this is where I want to talk about pain points. So like I said, I've implemented pipelines at multiple agencies for probably 50 plus development teams. So I've had the experience of having to manage multiple tech stacks and the corresponding pipelines that relate to them. And as someone that's had to administer these kinds of complicated, mature CI/CD pipelines, having to have a different Jenkins file for every tech stack is very challenging. Having to manage tools is very challenging, especially if you need to make changes. How do you do things like governance? So if I have multiple tech stacks across my organization and I want to make sure that everyone's doing static code analysis and doing container image scanning, but I have different pipelines for each of my different tech stacks, how can I assure an organization that these different security gates are being met? Steps have been taken through shared libraries to abstract out some of this code in a way that the common pieces can get pulled into these central repositories that have some common pipeline code. But at the end of the day, there's still a Jenkins file in every repository. So there's nothing stopping a developer from going and changing that Jenkins file to say, deploy to production and bypass all of these checks. And if you need to make updates to what that pipeline definition looks like, it can be challenging to scale that across an entire organization. So our solution for this is what we call the Solutions Delivery Platform. It's made of 3 components, and we're primarily going to talk about the middle one today. The bottom's the container orchestration platform, so that's your Kubernetes cluster. You don't have to build and deploy containers, but we've had a lot of success running our Jenkins and DevOps infrastructure on Kubernetes-based platforms. The middle is our pipeline framework. So this is a reusable pipeline framework that sits on top of Jenkins pipeline as code and gives you some swappability and governance. And then the top is a DevSecOps dashboard. Things like DevOptics and Hygia from Capital One are good examples of this. Your pipeline is really the center of all of the software development that takes place at your organization. And as such, it knows everything about what software delivery looks like for you. So if you could gather this data into a central place and try to identify bottlenecks in the process to try to find your pain points and accelerate your software delivery through gathering this data. So let's do a demo. As an engineer, if I see too many slides, I stop believing that it works. So I can end the slideshow. So I'm going to show you, this is a demo from a little bit ago. So primarily, how it is currently in most of the implementations I've seen, you have a Jenkins file in every single repository, one of the pain points we were talking about earlier. This is a standard GitHub organization job. And the difference with this is that we've written a plugin that we're calling the Common Workflow plugin. And what this does for you, I don't typically dive into the configure page, but it's Jenkins world. I do now. Can wiggle the cord a little bit? Okay, I did it on purpose so you can't actually tell. That's nice, I guess. I can't really show you the entire configure portion at this Zoom. I can also wave the cursor at the things I'm talking about because we're going to be on this slide for like 10 seconds. We good? Cool. All right. So traditionally, when you go to your configure Jenkins page for a multi-branch or a GitHub org job, what you'll see is that pipeline Jenkins file. It's your project recognizer that tells it which repositories and which branches have a pipeline in it. The plugin that we wrote gives you a common pipeline script from SCM or a common pipeline script in general. That's me waving at something that says common pipeline script. So what this does is it gives you a common entry point for all of the pipelines across every branch and pull request across an entire GitHub organization, which at first sounds like that can't be flexible enough, but we'll talk about sort of the way that we configure the pipeline at runtime. So what this does is give us that governance. So now individual repositories don't have to specify Jenkins files. We've abstracted that out of the repository to a common location, and then our runtime framework does a lot of configuring at runtime. So now if I go back, can I zoom out a little bit? Go to one of these jobs. I can go to a front-end application, go look at the code for this. This repository, like I've been saying, does not have a Jenkins file. Instead, it has a pipeline config.ruby file. We'll go into more detail in that in a second. I can open a pull request. And I currently inside OpenShift, which is Red Hat's enterprise distribution of Kubernetes. I have an application running. This application is currently running in production. It was really topical at the time for the Stanley Cup. It just shows you some data around the roster for the Washington Caps. So the second I kicked off that pull request, it kicked off a corresponding job in Jenkins. This should be familiar to a lot of you. When I go to the Blue Ocean view, I can see that without a Jenkins file, this pipeline and repository is inheriting the organizational workflow. And that organizational workflow is going to do things like static code analysis. It's going to build a container image, tag it, push it to a repo, do some container image scanning. After that, we're going to deploy an ephemeral application environment to test the change of this pull request specifically, and then do some 508 accessibility compliance scanning and penetration testing. So while it's scanning that container image, and just to note, for best practice's sake, you can't merge this pull request until the pipeline's completed, just to make sure that these tests actually pass and you're merging good code in so your teammates don't get frustrated. So while this is happening, we can sort of look at what's happening under the hood. So there's a pipeline configuration repository. So how we took out the Jenkins file from an individual repo, I now have an organizational repository that represents my pipeline configuration. We're going to dive into a lot of detail of what you can actually put in here. But the important things are that this is the Jenkins file that's being used. I swear it says Jenkins file. I know it's a little blurry. So there's a Jenkins file and a pipeline config file. We can look at the pipeline config file for this, which is going to be difficult at this Zoom. But this is going to specify things about your pipeline, like your application environments that you're deploying to, the stages of your pipeline, and the libraries. And these libraries are going to read a lot like your tech stack. So this repository is using GitHub Enterprise, SonarQube for static code analysis, Docker, Twistlock, OpenShift, tool called the Ally Machine for 508 compliance, and OWASP Zap for penetration testing. And then the actual Jenkins file itself looks like declarative, but it's not quite declarative. So this was intended to read as close to plain text as possible, and this is the business logic of your pipeline. So it's going to describe when I do something in GitHub, what does that do from a CI/CD perspective. So on commit, we're going to do continuous integration. This continuous integration method was dynamically created from that configuration file where it specified all of the different stages of that individual phase of the pipeline. Early on, we hard-coded what we thought were the best practices of what continuous integration meant, and it turns out everyone has a different definition, so we moved towards this dynamic method creation so that you tell the framework what steps involve each of those phases. And then ephemeral prod, so we're going to create an environment that looks just like production, except it is just for this PR. And then in parallel, we're going to do all of these kinds of testing. So penetration testing, accessibility compliance, functional, and then a nice exploratory testing so that I can show you the ephemeral environment. And then on merge to master, we're going to deploy to prod. So if we go back to our Blue Ocean view, we have our exploratory testing step, which is going to give us the URL of this application. So this application was created just for this pull request. This is a huge benefit. I've seen a lot with microservice-based development that if you have a common dev environment too soon and one microservice team breaks dev, it's broken for everybody, which can be challenging and sort of clog up your pipeline. So with ephemeral application environments, you're able to decouple microservice teams a little bit more. So this is running inside a container. We now have a new tab at the top. And it's a containerized database for this particular application. So if I click proceed, this is going to tell GitHub that the job passed. I can refresh this page, and I'm going to be able to merge the pull request as soon as Jenkins accepts that it's complete. And then on merge, if we refer back to that Jenkins file, right here, on merge to master, deploy to prod. This prod variable is dynamically created from that configuration file where you told us what the application environments were. So the idea was to make this file as easy to read as possible. If you need to change your workflow or your branching strategy that's represented, it's really easy to make that change. So let's go back to exactly how we did this and some of the benefits in there. If you noticed, those method names in the Jenkins file were very generic, things like penetration test, functional test, static code analysis. And the value of that is if I have multiple tech stacks in my application across my organization, or I have multiple tools to do static code analysis, I've got multiple kinds of languages being used. If only we could have multiple libraries that contribute the same step, and then depending on which library I load, I'm able to get a different implementation of that method. Right, so if I have unit testing and some of my teams are using Ant and other places in my organization are using Maven, if you load the Maven library, you can get a unit test or build method from that library and vice versa. So what this does is let you use a common pipeline template across an entire organization, and then based upon those configuration files, you're able to load the correct tech stack at runtime and execute your pipeline. So instead of having a different Jenkins file where most of it's been abstracted into libraries, but you still have some differences for the different kinds of tech stacks you have, this lets you define pipeline templates at the organizational level and then use this runtime configuration and dynamic loading of libraries to get the right runtime implementation. So it's broken down into 4 parts: govern, define, compose, and execute. Govern is those configuration files. So you have an organizational config file. It specifies the things that are common across the entire organization. So this is things like application environments, libraries. If everyone has to use SonarQube, for instance, that would go in your organizational pipeline config file. And then the organization gets to say which aspects of this configuration are allowed to be touched by the individual tenants of the pipeline. So for instance, if you're comfortable with your application development teams adding a new application environment, but they have to use the ones that we have declared, you can put merge equals true under that block in the config file, and now we'll aggregate the organizational config and the tenant configs and merge that into one based upon this conditional inheritance of what my organization has defined as acceptable customizations. That's what the granular configurations are too. Your tenants get to tell us at runtime what's unique about their pipeline. So that can be things like what URL is Zap going to test against. If I have a specific cluster or set of nodes that I deploy to, those are all things that are repo specific and would be declared by the repositories. Pipeline composition, we aggregate that all into one. We create a bunch of variables that make your Jenkins file easy to interact with, and we load the libraries. And then pipeline execution, all of the different libraries, it's expected they have some sort of organizational governance around quality. So for instance, SonarQube, you'll have your quality gate that determines whether or not the build passes. For Zap, you can set thresholds on what's an acceptable pass or failure rate. Each of those gates are tunable for the individual libraries, and it has that governance. So now when your pipeline gets to the end of it, you can rest assured at an organizational enterprise level that this pull request has met our organizational standards for what code quality looks like, without having to manage that or allow developers to have access to the Jenkins file to manage that process. So it's just Jenkins. What was so hard about this? We had to become Jenkins contributors to get Jenkins to do the sort of runtime behavior that we're talking about. So every pipeline method call that is a scripted pipeline is going to go through an implementation that we had to do. And we also created the common workflow plugin, which enables you to use that one Jenkins file across an entire repo or across an entire GitHub organization. And on the right is a bunch of verbose software engineering words for the things that are going on under the hood. The nice part about the SDP is that the end users don't have to know about all the complex pipeline as code that's going on. They provide a pipeline configuration file, and then the framework takes care of the rest, leveraging libraries to get reuse and leveraging the plugin and framework to get governance for your entire organization. So this is sort of a compare and contrast of why that organizational Jenkins file is so valuable to me. The typical Jenkins file, or what I've inherited occasionally, is like 750-line Jenkins files. It's kind of difficult to map, especially if you're using scripted, what's going to happen when from a branching strategy to CI/CD process perspective. If I need to do new tool integrations, it can be challenging to put them in the right location. So traditional shared libraries helped a lot with that, but it's still difficult. On the left-hand side, the SDP version of a Jenkins file, it's supposed to read exactly like your branching strategy. So the value here is if I want to add a new kind of testing tool, it's one line change. If I want to have a very specific branching strategy represented, that says on pull request to master, I'm supposed to point with my mouse. That says on pull request to master, that's a regular expression that matches branching names. So now I can create however complex a flow I want to and represent it in plain English in my Jenkins file. So this is the organizational config file that we talked about. It's going to describe which libraries to load, the configuration of those libraries, application environments, and things like what does continuous integration mean for me. And in this case, it means unit test, static code analysis, build, and scan container image. One level lower, this is the Jenkins file. We already talked about this. I always get ahead of myself for that slide. And then this is an individual tenant configuration file. So this is an example of what it might look like for a repository. In this case, it's telling OWASP Zap what the target URL to scan is. And then on the bottom, there's steps, which is SDP's default step implementation, which I'm going to get into a lot more detail in a second. So what all can it do? So from a value proposition, before I get into some of the in the weeds Jenkins stuff, is now your entire organization can use a common pipeline template or set of pipeline templates. You have the option of setting multiple and letting tenants choose which one they correspond to. Your Jenkins file is now 20 lines instead of 200, so making changes to that is very easy. The syntax we've created to interact with GitHub lets you represent as complex a branching strategy as you want in your pipeline without needing to rely on environment variables or anything like that. So what can I do? Default step implementations. So in Jenkins and specifically the SDP, all of our tools that we leverage in the pipeline are encapsulated in container images. So I have had Jenkins instances where I've got 3 versions of Java installed, 3 versions of Maven and Ant. And it was challenging to maintain that kind of configuration. With SDP, all of the tools are container images. So if I want to upgrade Jenkins, that's a matter of upgrading the container image that represents that build step, pushing it out there, and now the pipeline will inherit that upgrade. What this also means is that for steps in your library that are not currently supported by an SDP library or by a library that you've created, you can create a steps block in your pipeline config. Every key under that will become a method that's callable from your Jenkins file. So in this case, we're dynamically creating a unit test method. We're passing it a container image to use for that part of the runtime. And then we're passing it a command or script, if you choose, to tell it what exactly to do. And then finally, a stash block that says, is there any files that got created from this step that I want to hold on to for later? So that's been really useful. I've had situations where teams have 99% of the functionality they want out of libraries that we've been developing over the past year, but someone will have a very obscure case. So instead of writing an entire library for that, which would be nice to do eventually, you can get away with creating these steps dynamically on the fly, passing a container image, and now inheriting all the same functionality that you got as if it was a regular library step. Multiple pipeline templates. So I talked about this a little bit. If your branching strategy is represented in your pipeline template, but multiple teams have multiple kinds of branching strategies, I've learned early on that trying to do the one-size-fits-all does not work. We tried to start with best practices baked in, and we've done that in the libraries. But as far as what a pipeline flow is going to look like, that's very specific to individual teams and individual organizations. So you're able to create a pipeline templates directory inside your pipeline configuration repo. You can define as many pipeline templates as you want to, and then your individual repos can say use pipeline template, pass it the name, and then they'll use that pipeline template. Aspect-oriented programming. I'm pleased about this one because I figured it out last week. So this is the ability for library steps within SDP to register themselves to execute at specific timings. An example I like to give is if we have this dynamic runtime configuration of what libraries are being loaded. Let's say I have an email library and a Slack library, and they're both going to send notifications. I can't call email notify and Slack notify methods explicitly because I have no idea at runtime what methods are going to get invoked. So what you can do as a library developer within SDP is put annotations on library steps, and these are just like shared libraries from any other part of Jenkins. So that specific annotation says before step, and what that will do is automatically register the step to run before any other pipeline step that executes. And it will also pass a context variable that tells you what's about to happen in the pipeline, what's the current build status, what library contributed to the step I'm about to execute. So the different timing hooks that are available for library developers are before step, after step, notification, and cleanup. So after step has been really useful for things like logging instrumentation and metrics gathering. If I wanted to send events to Splunk, for instance, when I do a deployment, I don't want to put that logic of sending an event to Splunk inside each of my libraries, inside the OpenShift library, inside the Docker library. So what you can do is create a Splunk library, tag it with after step, and then you can abstract out that logic and do a different pipeline step, and it will automatically get executed after every event and be context aware of what just happened to be able to send events. Notifications, if you want to send a notification after the build step is complete, and when it fails, you have the power to do that. And then finally, cleanup steps. So if my pipeline is making a mess of things, creating images that I don't want to hold on to forever, I can create steps inside libraries that say at cleanup, and they'll get executed at the end of the pipeline. And then finally, custom DSL sandboxing. So those configuration files that we showed earlier are a custom DSL that gets parsed and aggregated at runtime. We started out with YAML, but we got a lot of complaints of I had a space missing or I didn't put a quote around something and my YAML file didn't parse the way I expected. But it didn't throw an error. I just didn't get the key where I thought it would be. So we thought about what's a better way to do this, and ultimately what we want is code. So we created a DSL. What this ultimately does under the hood is create a hash map for you, but it gets executed as a Groovy script. It gets executed as a Groovy script inside of a sandbox. So I think it's actually the original Kosuke's implementation of the Groovy sandbox that pipeline uses, except you can't do anything. So if you try to access the etc password file and set that in your configuration file, it throws a security exception. So we figured we can't create a framework to give you organizational governance and then allow arbitrary code execution. So the DSL files are protected against anything besides setting a key and value. And then finally, we have, so this is sort of if I'm a library developer, how do I interact with this framework? So those config blocks that we showed, libraries Slack username as an example. How does your individual library step get access to those kinds of fields? It happens by every step having a config variable that becomes accessible. So automatically, without having to do any wiring, to do anything at all, inside a notify.groovy, which will create a notify step, just like any shared library in Jenkins, you'll automatically have access to config.username because we defined a username in our configuration file. So you don't have to parse the aggregated config to try to find your library-specific configuration. It's just made available to you at runtime. So this is a big announcement for anyone that's heard of SDP. I don't recognize anyone here. But we're open sourcing SDP, which is a big step for us with a framework that's built upon libraries, the ability to open source it and have it available for people to contribute to this idea, trying to find ways to get organizational governance and reusability. Kosuke recently released that fascinating blog post called Shifting Gears, where he talked about pipelines as shared libraries as an extensibility model. I don't have enough hubris to claim that this is that way, but we've had a lot of success being able to create pipelines in what used to take 3 to 5 months in less than a day now. Because the second you have written a pipeline that can do SonarQube analysis or can do deploy to OpenShift, it gets encapsulated into a library, and now everyone can leverage that. So over time, as we encounter new clients that have new tool integrations that are required, it just means we add a new directory in our SDP framework, and we have that library for everybody to use. A quick note, it's open sourced under the Booz Allen public license. So Booz Allen has a license for open sourcing. There's a link to license info, and then links to the pipeline framework repository and the common workflow plugin. And then finally, documentation. So if you're interested in this, please reach out. I would love to talk about it. So does anybody have any questions? Not a single question. I'll ask questions for you.
How many government have you implemented that?
So we have implemented this at, I want to say 4 clients and at least 5 to 10 prototype efforts. So when we get the call that we need to create a prototype and you have 24 hours to complete it and show us what you got, with this, we don't have to think about it. You don't have to go find another repository where you had a similar pipeline, copy and paste it, and try to make it work for you. With this, we've been able to get it down to, once you have a OpenShift cluster, we've been getting a lot of demand for OpenShift and Kubernetes. So we've automated the deployment to OpenShift. Once you have an OpenShift cluster, deploying Jenkins with the right configuration and all the DevOps tooling takes 15 minutes. We have a Helm chart that deploys all the tooling.
So if you want to extend,
That's good.
right. So if you want to extend it to a different security tool that Government House or some other thing is not support SDP today, how do you do that?
All right, so there's 2 ways you can do it. So SDP, let me get out of slideshow and go to an editor. Cool, resources, SDP libraries. So these are the libraries. You can't read them very well on the screen that SDP has written stuff for so far. But SDP also supports external libraries. So if you had a custom tool or you have something that wouldn't be generally applicable to other teams, or we haven't gotten to it yet, if you have a regular Jenkins shared library, like anything else, as long as it's configured inside Jenkins and you put it in your config file, it will get loaded and benefit from the same config inheritance and everything else. So we did a mono repo for development ease and also for portability, but the ability to have external libraries is equally supported. Yeah?
I was wondering if you run stuff in parallel, can you set up the structure of your pipeline to run 2 stages in parallel?
Yeah, so the pipeline that we showed here is scripted pipeline. So there's nothing that you can do in scripted pipeline that you can't do in SDP. If you wanted to put node echo hello or whatever, it all works exactly the same. The pieces that are custom to SDP are this on commit and on pull request and on merge are just steps contributed by the GitHub Enterprise library. Continuous integration is a method that got created dynamically from your config file. But then this parallel block is just Jenkins scripted parallel. So that in parallel, it's running all of those tests. So you really have the flexibility to do whatever you want to do and just leverage the framework for as much or as little of it as you want. If you wanted to have a repo and not worry about the organizational governance because you just have a side project, you can do that. If you want to turn the governance all the way up and take away Jenkins Fall from the developers, you can do that. There's different flags inside these config files that you can set to dial that governance up and down. So as an organization, if I wanted to say it's OK if my tenants have their own Jenkins file, you can say allow tenant Jenkins file equals true, and now we will use a Jenkins file if it's present.
So when Jenkins Fall abstracts away, doesn't it make debugging for developers extremely difficult? Because they're like debugging proprietary scripts instead of like documentation that's out there already?
Yeah, that's a good question. So when I started on this path of DevOps and CI/CD, the culture was kind of developers should know everything and should do everything. Over the past few years, it's shifted a little bit to at least in my experience, there's a team that centrally manages your DevOps infrastructure and your CI/CD processes that are aware of all the underpinnings, and then the logging of these libraries and the way they output to the Jenkins build log should be sufficient for the developer to debug something. So if you had a build failure, you should be able to go to the console log, and SDP will tell you. We can go look at one of these logs.
Yeah, if you have a Maven build failure, is it going to output all the Maven?
Yep. At the end of the day, it's all exact pipeline scripted Jenkins pipeline. The only magic here is how we aggregate everything at runtime to give you this kind of framework. Within your build log, you're going to get nice SDP blocks before every step executes, and it's going to tell you which library happened. So if something were to fail, so right here, it's saying executing step static code analysis from the SonarQube library. So even if you couldn't figure out exactly what happened, you'd be able to look at the logs and see in which step did it happen and which library contributed that step.
So, do you check out your global libraries and the other libraries into your workspace into a specific job?
So the way it works right now is that we support external libraries. So if you have an external library that you want to load with SDP, that would get loaded separately. For all the libraries that come with SDP as a framework, they're all kept inside the same repository. So we've written some code that can dynamically load the right library. So even though we're loading the entire framework as a library to get you the different syntactic sugar, the individual libraries are not loaded until you put them in your config file.
What would be your preference for the global libraries? Should it be reusables or just shared libraries?
I think that there is a need right now for a way to get reusable pipeline components through shared libraries. So in a perfect world, once you've written your SonarQube library, there's no reason that another developer at Booz Allen or another developer anywhere should have to write that code again. So exactly how that gets organized, I think, is still open for debate. We've had a lot of success with the monorepo, but figuring out a methodology where we can leverage our collective effort to get that. I personally like the external repos for things that aren't suited for reuse. So if you have very specific tool implementations or you have a specific way to do it, I would do that. There's also the option of if you don't like the Docker library and you have an external library, as long as you name it Docker, it'll get precedence over the SDP one. So you can overwrite any of these with your own implementations. Yeah.
As far as deployment targets, is it Kubernetes exclusively?
It is Kubernetes and OpenShift from a libraries that we have. Are you talking deployment targets of the infrastructure or of the thing that's going to get built and deployed?
That deploy two-step.
That deploy two-step can be whatever you please. So We have written libraries for OpenShift because that's what we primarily work with. But if you create an EC2 library that has a deploy to step, and you want to build a war file and SDP it to some EC2s or something, that's perfectly acceptable. SDP doesn't necessarily care what is happening inside the methods. It's a framework for getting this reusability in governance and abstracting it out into a config file. If you wanted to have a separate repo that did data science workflows or did infrastructure as code workflows, or you want to use Packer to create AMIs, all you have to do is create the Packer library, and it will interact with Jenkins the exact same way you would expect it to now. And more so, you could have your data science and infrastructure as code and software development pipelines all encapsulated in the same location, abstracted out from any individual team. Does that answer your question?
Yeah. One other one. I noticed you put an input step in there. Does that facilitate like QA sign off?
Yeah, in this case, that's kind of more of a philosophical question than a technical question. But in our case, we had the input step to be able to go look at the ephemeral application environment. Otherwise, it would have gone away. So yeah, you can have input steps just like you would now. They're typically used for things like security gates and QA testing. Just to reiterate, the Jenkins file and the different pipeline templates are just scripted pipeline code that execute exactly as they would now. So anything that you can do in Jenkins right now, you can also do inside of these pipeline templates. It's just you now have this syntactic sugar and framework to make things a little bit easier for you. Any other questions? Yeah.
You were mentioning scripted pipeline support. Do you support the declarative pipeline, or is that just...
So I would love to. Because of the level of meta programming that we had to do to get this kind of behavior, declarative seemed a little restrictive. I'm certainly open to revisiting it and seeing if we can make it work within declarative. Ultimately, all of these things are getting contributed as library steps, so I don't see a reason why the two couldn't coincide. I just haven't had a need to focus on supporting it. It would be nice because you get a little bit more blue ocean integration through declarative than you do through scripted. Yes?
Do you automatically create your OpenShift pipelines when you do an organization scan?
So yes. So do you automatically create your OpenShift pipelines? Before I say yes, what do you mean specifically? Do you mean the build config pipeline within OpenShift, or do you mean the ability to deploy to OpenShift?
The build config or the pipeline?
So we do not build the build config right now, but it's open source and the OpenShift library is there. So it would just be a matter of when the OpenShift library gets loaded, creating a build config. So each of these, there's a lot of features, so I'm going to forget a couple. Each of the libraries can have what's called a library constructor. So when you load the library, if you want specific things to happen from a configuration standpoint, any code that's not inside a step takes place. So for instance, in the GitHub Enterprise library, you really can't read this, but it's just scripted pipeline that's not inside a call method. So what that means is that when I load the library, this code executes, and it does things like set environment variables that give you information. So for your specific use case, you'd create an OpenShift constructor that would create your build config when you loaded the library. Any other questions? Yes.
You had the concept of things running before or after. Would there be the case where there'd be two things that needed to run before and you wanted to control the order or something?
We haven't had the use case, but there's no reason you couldn't. The way that works under the hood is we look in the meta class registry to find all the methods that have that annotation. So instead of just invoking them as we find them, we could order them based upon some preference. The nice thing about this framework is that everything is just code and everything is overridable. And so if you didn't like the way libraries got loaded, for instance, you could have a custom load libraries method and override our implementation. And because it's all just code, things like that are just a matter of getting more use cases and finding the extension points and abstractions that we missed, which I'm sure there are some. Yeah.
Your framework implements unit tests over the pipeline. In their own libraries, like it's scripted and in Groovy, so I can
You mean testing of the libraries themselves?
Yeah.
Not yet, but I'm very excited for a talk tomorrow about Jenkins unit testing. And if anyone has good solutions for that, please come tell me. It's going to be challenging because of some of the custom stuff we're doing here to try to find a testing framework that's going to incorporate with that. So we're likely going to have to write mocks that sort of step into the framework and set things up for you. But it's definitely on our short-term roadmap. No other questions? Thank you for coming and listening.